Hello, everyone, and welcome to Wind Down Friday. Today, our special guest, is Doug Sparks, author of a book titled "A Decade in the Chinese Semiconductor Industry: An American's Story," and the CEO of M2N Technologies. Hi, Doug. Welcome aboard. How are you?
Hi, it's great to be here.
Thank you. Thanks a lot for being here. So, where are you located, Doug?
I'm in the Midwest near Chicago.
Good. So let's start. So I have prepared a couple of questions in particular related to your book, latest book. But before that, let's talk a bit about you. So from university to becoming the CTO of Anking Electronics, the founder of Nanogetters. Now, as I mentioned, the CEO of M2N Technologies. So your career spans a wide range of roles and countries. So, could you walk us through your career journey and share how these diverse experiences have shaped your perspective on the semiconductor industry?
Well, sure. I went to Purdue University. I was a material science major. I specialized in semiconductors. Uh, After university, I went into industry, worked in wafer fabs, as a process engineer, and then as a development engineer, a MEMS device designer, and eventually manager in the automotive industry for General Motors divisions. I went to some startups at a University of Michigan spinoff that did microfluidics. I started my own company called Nanogetters, which was a vacuum packaging, which dealt a lot with resonators, gyroscopes, timing devices, and things like that.
Mhm.
Then an old friend of mine, I met her at a conference, and she said, "Hey, I'm building a new wafer fab in China. I'd like you to help me." So that's when I joined Hanking Electronics. And I thought that would be like a 1 year project, and it turned into 10 years of working with the Chinese semiconductor industry all over the country there, with suppliers, building fabs, ordering equipment, doing acquisitions and things like that. And then after COVID, things kind of shut down there. So I've started back up in just consulting. So I work in Europe, the US, Asia as a semiconductor and sensor consultant.
Good. So let's talk about your book. So, A Decade in the Chinese Semiconductor Industry and Americans' Story. So, what inspired you to write this book? Was there a particular moment or experience that compelled you to share your insights?
Well, I had kept a journal as I traveled through China on my computer. So I'd have all these funny stories and old emails that I'd send out and headlines. And then during COVID, I thought, I had some free time like all of us did. We were at home, and I thought I could put this together into a book. And it would be kind of interesting because then we were starting the trade, the chip shortage and the trade friction, and COVID came out of Wuhan, those kind of theories. And I thought it would be a topical book. So I put that together and published that late last year.
Nice, and it's a great book. So in your book, you highlight several pitfalls. So in the Chinese semiconductor industry, could you share an example of a challenge you observed and how it reflects the broader dynamics of the global semiconductor market?
Well, one of the most interesting things, China has put lots and lots of money in their three big funds, hundreds of billions of dollars, similar to what the CHIPS Act in the US and Europe did. They did it in three stages to try to improve self-sufficiency. And when the central government says we've got to build wafer fabs, every province built a wafer fab, even though they had no infrastructure, no no people in those far western and northern provinces to support the industry. So there were all these wafer fabs that were built. The government officials were happy that there was a building, but the equipment wasn't ordered, or the wafers were not run. So there's a lot of empty fabs as the result of these centralized mandates without full support to build, to equip and start running wafers and hire people and train people. So that was one of the big pitfalls I noticed.
So you discuss scenarios like a potential invasion of Taiwan or South Korea and their catastrophic effect on the semiconductor industry. So how do you think the global industry can prepare for such a possibility? So and what about TSMC talking Taiwan?
Yeah. I mean, that was, it's a very low probability event, but, you know, again, I don't know if you remember a few years ago, China started having like a wolf warrior mentality where they were very aggressive, with other countries. They were building military bases in the South China Sea. They were every year they threatened to invade Taiwan or reunify. And I believe after the chip shortage during COVID, the Western governments realized how precarious our supply chain is for semiconductors. And, obviously they started CHIPS Act to build wafer fabs in the US. But they also put a lot of diplomatic pressure on Taiwan, TSMC and Samsung to build fabs in the US and Europe and Japan. And so you actually saw that happening. And, during, right around COVID, Morris Chan said, the founder of TSMC said it would be crazy for us to build a fab in the US. It's too expensive. But then after these geopolitical events happened, they built a fab.
Hmm.
And at one of their board meetings a year or two ago, they admitted they built it for geopolitical reasons because the US said we have to have a 5 nanometer fab in the US because it's too dangerous to have everything in Taiwan with the threat of an invasion or the threat of a blockade or something like that. So I think we've really seen that the governments have responded to that potential disaster because if there was a military invasion of Taiwan and the fabs were damaged, it would be a worldwide depression if we lost the ability to make iPhones and automobiles and EVs, which would happen if we lost all the TSMC and Samsung foundries.
So, having spent over a decade in China's semiconductor sector, what are the most valuable lessons you have learned about working and living there?
Well, I just want to say that working with the Chinese people was a great experience. They were very friendly. They really want to build the semiconductor industry there. However, there are economic and political and governmental barriers in some cases that limit things. Um, but they are very determined. There are wafer foundries like SMIC and H Grace's foundries that are running at good full capacity. But the majority of the other fabs are not running at high capacity, so they're losing money. In a Western economy, they would be shut down and bankrupt, but they're kept going from a centralized, economic perspective. They just keep working on these projects and building wafer fab capacity.
So, let's talk about the situation in terms of control of export. So, USA export controls have significantly limited China's access to advanced semiconductor technologies, constraining its ability to produce high performance solutions, chips, in this case, essential for various industry. So, in response, China is investing heavily in domestic technology, domestic semiconductor development, organizing partnership, collaboration, fostering partnership, and exploring alternative technologies to mitigate these challenges. How are USA export controls impacting China's semiconductor industry? What strategies is China employing to counter these restrictions?
So, I mean, the US is working through their allies like TSMC and all the equipment suppliers like ASML to restrict the sale of finished wafers. For example, the Huawei, smartphone chips that were um, at one time were leading edge wafers from TSMC. Those have been restricted. Now, China has found ways to use third party design groups in China and in other Southeastern Asia countries to get those chips to Huawei. They recently had a new announcement where it looked like they had a 7 nanometer chip in their phone. Turned out it wasn't made in China, it was made in TSMC through one of these third party groups. So the restriction of chips and wafers is one way. The other way is the restriction of equipment like ASML, EUV tools, applied materials, Lam, KLA tools. Those have been restricted. The government of China is funding companies internally, Chinese companies, to make their own wafer fab tools. There's still concerns, with the exception of AMEC, there are still concerns of the reliability of these tools that are made in China, but they're good enough mature nodes. They may have poor uptime compared to applied materials or a KLA tool, or they may have slightly or lower yields over time, but they can make wafers. Whether they can be competitive with TSMC or Samsung, that remains to be seen.
So the growth in terms of electric vehicles, so the rapid growth in China's EV exports, so would rely on its robust semiconductor manufacturing capabilities for EV components like power management, integrated circuits, battery systems, and so on. So, however, concerns about overcapacity in both the EV and semiconductor industry are emerging, so driven by aggressive expansion and fluctuating global demand. So, what is the connection in this case between China's EV export boom and its semiconductor industry? How do you see the EV market in general?
Well, I mean, China, with its centrally planned economy, has done this previously. They did this with solar panels, where they focused a lot of subsidies and just central guidance to build solar panels, and it put Germany out of basically put their solar panel business out. Very, very, really damaged Germany's solar panel industry. It's done the same in Brazil. It's done the same in the U.S.
Mhm.
We saw this with LED light bulbs and the LED chips. Heavy government subsidies for semiconductor deposition tools to make the LED wafers and then eventually make the light bulbs. We saw it with turbines, windmills. We've seen it with EVs. Now, a lot of the EV chips are purchased from Europe and the US, although now they're trying to make their own chips, their own EV power chips. So this constant pattern of heavy government subsidies, exports, puts the Western companies out of business, and then they corner the market. So they're repeating it again with EVs. We've seen Volkswagen laying off people and closing plants for the first time in decades. Um, but people are putting up barriers. So the U.S. pretty totally shut down Chinese imports of EVs. More tariffs are being put in Europe. The same thing's happening in South America, and as well as Southeast Asia. So the governments realize that this is kind of a stealth way to degrade your economy by cheap exports to your country. And so the fear is the same thing's going to happen with semiconductor ICs, mature node ICs. They're building a lot of fab capacity, so they will be able to export consumer grade devices and potentially flood the market with inexpensive chips.
So the semiconductor industry is not only critical to technology, but also plays a role in addressing climate change. So as one of the largest global players, so China's path could have a significant impact in this regard. So how do you see the semiconductor industry contributing to climate solutions? What role can China play in driving sustainability initiatives, sustainabilities programs within the sector?
Well, I mean, solar panels is the perfect example. That's a silicon, huge amounts of silicon is consumed for making solar panels. Probably more silicon is used in solar panels than all the ICs put together. So that's one big renewable resource. And then all the power drivers, all the, I guess you would call it BCD MOS chips that are used to make electric vehicles is another example. So there's a lot of silicon that goes into electric vehicles, and there's a huge amount of silicon that goes into photovoltaics. And I think China was betting on the West's push for green technology, that they would accept the low cost Chinese solution and they wouldn't get the tariffs and pushbacks that they're seeing. So they were kind of betting that, Western Europe is so green that they're going to take these. I mean, and it makes sense. If you're in the Green Party in Germany, you would want solar panels and electric vehicles. So, China can make them very cheaply. So why not take them? Well, then, so you take them and then you lose all your manufacturing jobs. So that's the thing you got to balance.
Thank you, Doug. So, in conclusion, my last one, like takeaways that you would share with our audience. So, with your international experience in Japan, Europe, and USA, United States, where do you see the semiconductor industry is going forward, heading in the next decade? So, especially in areas like AI, data centers, electric vehicles, as you mentioned, telecommunications, for example, and considering also the growing competition between USA and China. So, how do you think this competition will influence the future of global semiconductor landscape and its technological advancements?
Well, clearly, without semiconductors, you can't have artificial intelligence. You can't have solar panels. So it's going to be there.
It's
You can't have
clear.
electric vehicles. But I think what we're going to see now is we're going to see separate supply chains, which is going to raise the price of everything because we're no longer going to get global leveraging on chips and silicon. So it's going to cost a little bit more than we planned on it. Originally we had this big global semiconductor supply chain. Now it's going to be segmented, into two or more local regional supply chains.
Thank you, Doug. Thanks a lot. It has been a great conversation with you. Thanks a lot for joining us, me, at Wind Down Friday, and stay in touch. Have a good weekend. See you next. Thank you, Doug.
Okay, thank you.